Hello, ladies and gentlemen. Today, I would like to just go over my calculus 2, exam number 1, and this is about integrations. So, my students, hopefully you guys are watching, we have a class in like 2 hours. And I haven't finished creating your exam yet, so I want to just make the solution for you guys first. And you guys can find the file in the description. And if you're taking Calc 2, hopefully this is also helpful for you as well, right? So let's just get started. Again, go to a description to download the file, and we'll just get started right now. All right, so for the first one, we have to integrate e to the inverse tangent x over 1 plus x squared. Well, for this one, it's not so bad. You just do a u substitution, let u equal to the inverse tangent of x. This is actually du will give you 1 over 1 plus x squared dx. So as I said, it's actually not so bad, because we do have the 1 over 1 plus x squared right here already, right? So if you take this to the u world, you see this is just the integral e to the u. And if you would like, you can just pair this up. And that's exactly what we have for the du. So you see this is just going to be, the answer is just e to the u, but u is inverse tangent, so you just get e to the inverse tangent of x, and then we are done, plus c. Yeah, what's the cat? Yeah, anyway, that's it. So it's just like a warm-up question. You don't even have to show the word for that. The first 6 questions are multiple choice for the people, for my viewers, if you are in my class. All right, for the second one, perhaps I'll pause for a little bit to ask you guys a little bit, right? Which of the following is correct? We have all these integrals right here and all these answers. And choice E is all of the above. So in another word, maybe everything is correct. So I'm going to look at the chart right here just to see like what did you guys come up with, right? So let's see. What do you guys have? Which one of this is correct? My beard made me look like a philosopher. Thank you so much. Okay, great. A lot of you guys are saying the correct answer. The answer is E, right? All of the above. So everything is correct, of course. Yeah, so let's move on to question number 3. And I have to also look at the computer for my questions right here. And let's see. This one is about partial fractions. So here we go. Number 3, we have to integrate. And we have 5 over x minus 1, and then x minus 2, and then x minus 3, and also the dx, like that. This right here is actually not so bad because we can do the cover up. You will see that I will be saying this is not so bad throughout the whole video because, yeah. Anyway, so first fraction, we have something over x minus 1 plus something else over x minus 2 plus something else over x minus 3, like this. Now, we are going to use both hands, or maybe use the Pokeball. To figure this out, we have to go back to the original and cover this up. And we have to ask ourselves, how can we make x minus 1 equal to 0? X has to be 1, right? So you just put 1 in here and 1 in here, and just do the work. 1 minus 2 is negative 1. 1 minus 3 is negative 2. Negative 1 times negative 2 is 2. And we just have 5 over 2. So this right here is 5 over 2. And then we continue. For this one, again, we can do the cover up. Go back here and cover this up, and we have to make x equal to 2. And we put 2 in here and here. We cover this up already. I'm kind of nervous because I haven't done live stream for a while, but anyway. Well, actually, that's not entirely true because I'm teaching on Zoom, but like, I don't know, it's just, let's see. There are a lot of people watching me, so that made me slightly more nervous right now, so. All right, put 2 in here, you get 1. Put 2 in here, you get negative 1. So all in all, on the bottom, we get negative 1. 5 over negative 1, we get negative 5. And lastly, cover this up. Put 3 in here and put 3 in here. We get 2 times 1, which is 2. 5 over 2, like this. All right, then we can just integrate term by term. So for the first one, well, we get 5 over 2. And luckily, this is just a linear function on the bottom. So we get a natural log. And we have the absolute value. And this is x minus 1. And notice that the derivative of the bottom is just 1. So divided by 1 doesn't matter. Next, same thing. Minus 5 ln absolute value x minus 2. And last one, plus 5 over 2 ln absolute value x minus 3. And then plus c. We are done like this, right? All right, enough. I know enough is enough, right? All right, let's go back to question number 2 before I erase. Yeah, I know this is not the answer. Just taking my time to erase it. All right, so let's come back to number 2 again. Notice that I purposely wrote this question so that everybody here has the third power, and I just purposely did the power rule to everybody, right? We'll notice that the base right here is sine x. The base right here is x minus 9. The base right here is ln x, and the base right here is 2x plus 1. You can only do the power rule if the base is a linear function, and hopefully the derivative of this is just equal to 1. And in fact, B is the correct answer. B is the correct answer. Let me just put this down. Because on the exam, some people will ask me like, did I really mean all of the above? Or did I mean none of the above? B is actually correct. This is actually legitimately because you can let u equal to x minus 9, and du will be the same as dx. So integrating u to the third power, we get 1 over 4 u to the fourth power. And u is just the input, so we are done. However, if the base is sine x, if you let u equal to sine x, unfortunately, you will have a cosine x, right, in the integral. So that's not the case, so we cannot do that. Likewise, for this one, you actually have to do integration by parts. And this one, well, it's similar. But if you let u equal to 2x plus 1, du will be 2 dx. So when you do the entire derivative, you actually have to divide it by 2. This will have been correct if it's 1 over 8, right? But A and C, they are totally not the answer. Yeah. So that's it for question number 2. Yeah, okay. All right, so let me just go over all the questions, and maybe you guys can chat among each other. That would be great. And I'll also be taking a look at the chart as well. So let me know how you guys are doing. Maybe you guys are taking classes online. I don't know where you guys are from, so let me know. Right now it's 2:28 p.m. in LA. So these are the things that I have right now. All right, so I'll continue. Number 4. Here we have to integrate cosine 2, well, cosine to a second power x dx. Again, this is not so bad. Yeah. Here we go. Well, to integrate cosine to the second power, we have done this in class with sine to the second power. For cosine to a second power, it's very similar. We just use the power reduction formula, or just the identity, right? And let me tell you, this right here is actually the same as 1 over 2 times 1 plus cosine of 2x. So this right here is just the identity from the cosine square x. And then go ahead, still have the integration. I put the 1/2 in the front already. And now just do the work. Here we have 1/2 times the parentheses for the result of the integration. Integrating 1 in the x world, we get x. Integrating cosine, we get positive sine. So we still have positive sine. And the input can stay the same because the derivative of the inside is just 2. But remember, when you do the antiderivative, you have to divide it by 2. So we have the 1/2 right here. And that's pretty much it. And then we can just go ahead and distribute this. So finally, the answer is 1/2 x plus 1 over 4 sine of 2x. And of course, don't forget the plus c, otherwise the cat will be sad. All right, so that's it for that. Now, number 5. integrating secant x dx. Well, for this one, it's a multiple choice question, right? You guys can see that. So it's just kind of like a quick questions for the students again. If you remember the result, which you should, then that's pretty much it. But if you really don't want to just impress me, which you shouldn't because it's taking a test. But anyway, I'll do this for you guys. The standard way to do this is that you multiply the top and bottom by not only secant and not only tangent, but rather secant x plus tangent x. And then secant x plus tangent x, like so. And because when you do that, you can just let u equal to the denominator, secant x plus tangent x, and you will see du is precisely the derivative of this, which is secant x tangent x, and the derivative of this is secant square x, and then we have the dx. Guess what? This right here is exactly what we have on the top. Secant square x, secant x tangent x. So in other words, the top is again the du, and the bottom is just the u. So all in all, if we integrate 1 over u, we get ln of u. So I'm just going to write down the answer. And u is what? U is that, namely secant x plus tangent x. And we are done. Done, done, done. Just like that. But again, you didn't even need to show me too many work because it's just meant to be, it's a multiple choice. So choose the correct answer and that will be it. So let me take a look at what you guys are saying. Thank you guys so much for turning to watch the live stream, and for the people who say hi to me, hi back to you. Hello from Hong Kong. Oh, hello from UK. I'm sorry. So hello from LA. All right. So maybe at the end of the live stream, I will do a quick little Q&A, whichever question that you would like to ask. All right. But now let me just get this done. So let's see the next question. Are you guys looking at the file? Just wondering. All right, number 6. We have a Pikachu question. That's almost like my tradition during these years. But anyway, Pikachu is trying to integrate the integral of x squared times the square root of x squared minus 1 dx. And this test is just all about integrations. But anyway, now Pikachu is trying to integrate this, and he's using the substitution that x is equal to secant theta. And your goal is to help him to figure out what integral will he get in the theta world. So we just have to do the usual business. This right here is the substitution that we have to use, and then just continue. Well, don't forget to do the dx. Differentiating secant theta, we get secant theta, tangent theta, d theta. And now we just have to put everything back to the original integral. So we have the integral. Put this here, we get secant square theta, and then square root of secant square theta minus 1. Secant square theta minus 1. And then the dx, I think this is the part that a lot of students will miss. This part, don't forget, we still have to put down the secant theta, tangent theta, and in the end we have the d theta, right? And now have a look. This right here is what? This is nicely equal to tangent square theta, right? And then we are still in the square root though. And remember, square root and square root cancel, and you don't have to put down the absolute value because this is just a definite integral. So as I said, you don't have to worry about that. You can just cancel them out nicely. So in the end, we see that this is nicely equal to secant squared times secant. So we have secant to the third power, and then theta, and then tangent theta, tangent theta. So that's tangent square theta, d theta. And you don't have to continue because this right here is just meant to be a, again, quick question. that if you can just take the integral to the theta world for the Pikachu. That's all. And to integrate this, let me tell you, it's actually not so easy. That's why I didn't ask you guys to integrate it all the way. So that's pretty much it for the multiple choice part. And now let me go through the short word questions. Right. So for number 7, it will take me a few space. So I'm actually going to, actually I don't need to. All right, here we go. Number 7. Let's go ahead and integrate 1 over 1 plus x squared times, well, not times. Take this to the 3 over 2 power dx. Well, perhaps I will ask you guys for help. What should we do for this one? I think this is a pretty good time for me to just discuss the integration with you guys. What should we do with this one? So help me out. Tricks up, and then if you tell me tricks up, then what shall we do exactly? Which function should we use? Which function should we use? Tangent. All right, great. So right here, I'm just going to let x equal to tangent theta. And this right here is kind of similar to that, right? Anyway though, dx is equal to secant squared theta. So let me actually just write this down right here so I can make sure I have more space later on. All right, now take this integral to the theta world. This right here is going to be the integral 1 is still 1 over 1 plus, this is tangent theta now, so we have tangent, and that's square, and then theta. And then you put this to the 3 over 2 power, and the dx is that, namely secant squared theta d theta, like so. All right, what's 1 plus tangent squared theta? It's kind of similar to that, right? This inside is secant squared theta, which is pretty nice. And then we take this to the 3/2 power. Well, multiply the powers, this becomes secant to the 3rd power. So this right here is actually just integral 1 over, this is secant to the 3rd power, right? Theta, because they cancel for the 2. And then here we have secant squared theta d theta, and more cancellation is happening. 2 of this and 2 of that, so we have just 1 more. So here we have to integrate 1 over secant theta d theta. In another word, we have to integrate 1 over secant is just cosine theta d theta, and the integral of cosine theta d theta is positive sine theta. Right? And we are not done yet because we have to go back to the x world. And to do so, I'm just going to look at this right here. So we know this right here. So put it down. X is equal to tangent theta. That means tangent theta is equal to x. And more importantly, look at this as x over 1. By doing so, we can draw a right triangle, put a right angle here, and then the theta here, so we can figure out the triangle. This right here is opposite over adjacent, so here we will have x over 1. X right here and 1 right here. And to figure out the hypotenuse, of course, what we do is 1 squared plus x squared and the square root. So just like that. Now, looking at this triangle, we have to figure out sine theta, namely opposite over hypotenuse. So all in all, this right here is nicely equal to x over square root of 1 plus x squared, and then we are done. So go ahead and put down the plus c. This right here is it. Yeah, not so bad, right? Yeah, even though I say it's not so bad, like throughout the whole test, and some of my students will still complain, the test was so hard. Yeah, so anyway, the life of being a teacher, just yeah. But if you really did study, like if you go review all the homework and lecture and watch the videos I provided, you should totally be fine with the question. All right, so next one, we have natural log x to the second power. So this is number 8. Integral, parentheses, natural log of x to the second power dx. And again, take a look at this integral, and I will ask you guys for help. I'm looking at the chart right now. I'll take suggestion. What shall we do with the integral ln x, but the whole thing to the second power? And before you guys tell me, if you put this to the front, that's not correct. Right? This right here, it's not the same as ln x squared. If this is the question, yes, you can put a 2 in the front. That's totally okay. Because this means natural log of x times x inside. But this means natural log of x times natural log of x. So there are two very different questions. Alright, so hopefully you guys answer this in the chat, and let's see. IBP by parts. And let u equal to ln x. That's actually a much better way, because if you want to do it by parts as how it is, you have to run through a dm method twice, and you have to do it 2 separate times. But if you do a u sub first, the u sub first, the IBP, the dm method is just nicer, I would say. And by the way, if you're taking Calc 2, let me know in the comment right now as well. That will be cool. Okay? But I'm teaching Calc 2, that's why you guys see me that have the Calc 2 videos pretty much all the time. Yeah. And is this camera okay? Is this camera angle okay? Or should I move it closer so you guys can see better? Okay, cool. So you guys, some of you guys are taking BC, and alright, great. So for number 8, I will actually do a u sub first. I'm going to let u equal to the whole thing, namely ln x. Sorry, not the whole thing, just kidding. I'm going to let u equal to ln x. Why? By doing so, you will see that du is equal to 1 over x dx. And dx is just going to be multiply the x on both sides, so you get x du. Well, let's take this integral to the u world. We will end up with the integral. This is the u, and then we have that to the second power. And the dx is x du. That's no good, because x is not invited in the u world. And there's now x on the bottom to cancel with this x, right? So that's no good, but it's okay. It's not so bad at all, because if u is equal to ln x, what does that mean in terms of x? Well, do e to this power, e to that power on both sides, they cancel. In another word, x is nicely equal to e to the u. So right here, this x, I'm actually going to put this down as e to the u, and then we have the du right here. Right? So now you notice this right here, it's actually a nicer version of the integration by parts, right? If you do the dm method on the side, plus, minus, and some people don't like the dm method, so in that case, what you can do is, if your teacher doesn't allow you to use the dm method, if your teacher wants you to use the u dv method, just put on u and dv to make them happy. And then still go ahead. This right here is u squared and then e to the u, right? So I'm going to differentiate this 2u to 0, and this right here is just e to the u, e to the u, e to the u. I am not using the dm method. I'm using the udv method, the traditional udv method that people, keep telling me that I have to do this. All right, multiply, that's pretty much the answer. So here we have u squared e to the u, and then minus 2u e to the u, and then lastly we have the plus 2e to the u. However though, what is u? U is natural log of x. So right here, we will have natural log of x and then square. So put a parentheses and square that. That's for this one. What's e to the u? E to the u is x. So put that right here. E to the u is x. Perhaps I'll put this down in I think it's black and white, it's okay. Next, right here, minus 2. U is ln x. I'll put it down right here. And then e to the u is x, so I'll put that in the front. And lastly, e to the u is x. And then we have the 2, right? So plus 2 x. Just like that. And then we're done. Plus c. And that's it. Sorry, wrong color. X right here, as I said, should be in black. So if you look at x is equal to e to the u, like that. Right? The udv method, this is not the di method. All right, take a look, and now we'll continue right here for number 9. Right, so let's see. Number 9. Oh, it's a pretty big partial fraction one. So I'm actually going to erase number 8 as well, because I think this is going to be the one that takes the most computations, in my opinion, for the test. And the other ones, if you know the method to use, then you pretty much will get a question right in a pretty good amount of time. So number 9, here we are integrating 6x squared minus 7x plus 32 over x minus 4 times x squared plus 4. Man, I don't feel like doing this. It's partial fractions, but like if it's on the test, I have to do it too, right? So anyway though, let's just go ahead and break this apart. So I will do the partial fractions right here. So when we have the, let me see, right here, 6x squared minus 7x plus 32 over x minus 4 times x squared plus 4. Well, the first guy will have x minus 4 on the bottom, and the top is just going to be a constant. And for the second guy, we will have x squared plus 4 on the bottom, but the top will be a linear factor, so we get a bx plus c. So make sure we have to have the correct setup, right? All right, for A, it's not so bad because we can do the cover-up method for this. Go back to the original, cover this up. X has to be 4. So when we put x equal to 4, put it into all the x. So we get 6 times 4 squared minus 7 times 4, and then plus 32 over 4 squared plus 4. All right, so on the bottom is 20, and then on the top, this is 16, and that should be 96 minus 28 plus 32. So that's 4, and then so that's 100 over 20, which is 5. Okay, so erase this so that nobody can see what I did. Haha. Yeah, anyway, that's A, that's good. But now for the B and C, unfortunately, we cannot do the cover-up for that. So I'm just going to multiply everybody by the original denominator. So I'll put this down right here, x minus 4, and then x squared plus 4, right? Well, when we do that, the left-hand side is just this. So I'll put this down, 6x squared minus 7x plus 32. Take this times that, the x minus 4 will cancel. So this is just 5 times x squared plus 4. Take this times that, we get plus bx plus c, which we don't know yet. So bx plus c. And the x squared plus 4 cancel, we have the x minus 4. Right? Just like that. So it's not so bad. Now we just work this out. This right here on the right hand side, we get 5x squared plus 20. Multiply, we get bx squared, and then minus 4bx. And then this times that is plus cx. And lastly, we have the minus 4c. I'm sorry about this thing right here. And minus 4c. And hopefully you guys can see okay. All right, now combine terms, this and that. Both of them have the x squared, so we write it as 5 plus b, and then x squared that. Next, this and that have the x, so I will put it as plus parentheses minus 4b and then plus c. So minus 4b plus c and then dx. And lastly, we have the 20 minus 4c, so the last part is plus 20 minus 4c, right? So that's the last part, plus 20 minus 4c. So that's what we have. Now we can just equate coefficients because you see that on the left-hand side, we have 6x squared. So that means this right here has to be the same as that. So just go ahead and real quick. 5 plus b equals 6. b has to be equal to 1. And you can use the middle term because you know b is 1 already, but I will use the last term. Why not? This is 32. This is that. So 20 minus 4c is equal to 32. Move this to the other side, we get positive 12 divided negative 4, so we get c equal to negative 3. Right? So that's all we have. Perhaps I'll put this down. b is equal to 1 and c is equal to negative 3. Did I get this partial fraction right? I'm not looking at the solution, I'm just looking at the chart to see if I get this right. So what do you guys think? Did I get this right? Hopefully that's the case. I guess just watching for fun or actually thinking and doing the math along the way. Let's see. Cool. Oh, by the way, in the meantime, I want to show you guys, this is what I got recently. Haha, this is my canvas print and for the integrals for you. Pretty cool. Yeah. I'm actually thinking to do a competition, but because I teach at community college, so I want to just try to encourage the community college students to also get into math and get into making videos. In fact, for this semester, it's my first time that I'm making my students to do video projects. And they will do 4 video projects for a semester. That's a lot of videos for me to watch. Yeah. But anyway though, I'm offering them that the best one, I will give them either a canvas print or a t-shirt of their choice, so up to them. And they submit the first video project already. The first video project is about show me 3 integration techniques. Integration by parts, trig sub, and also partial fractions. And the best one in the class, I will offer them either this or a t-shirt. So I'm thinking if I should make a post and just make a contest for my viewers in the United States, especially in the community college, so that we can do the same as well. I don't know yet though, so let me know if you guys are interested. Yeah, so this right here. Well, it has no partial fractions here, but oh, let me see. It does have the trig identity. That I should have used this earlier, but well, come on, start myself. I remember all that, so yeah, no big deal. All right, enough talking. Here, this is integral. All right, a is 5, so I'll just put this down in blue and red. Here, we have 5 over x minus 4. Next, I'm going to split this fraction, x, right? This is just 1x over x squared plus 4. So plus 1x, right? You can just put on x over x squared plus 4. And lastly, minus 3 over that. So we have minus 3 over x squared plus 4, like so. And then don't forget the dx. And perhaps I'll erase this a little bit. I'll still show you guys the work right here. And some people tell me that I should really put down parentheses right here. I don't really think so. I think this is totally okay. Anyway though, I'm the teacher here anyway. So integrating 5 over ln, that's the answer. Integrating 5 over x minus 4, we get 5 ln, right? So 5 ln absolute value x minus 4. Good. Next, we have x over x squared plus 4. You can do a u sub real quick. Let u equal to x squared plus 4, and the derivative of u is 2x. Well, here we only have x, so be sure you divide the 2 as well, right? So it's like multiply 2 and divided by 2. But anyway, Go ahead and do that on your own, and you should get plus 1/2. Also natural log situation, and the input is x squared plus 4. With parentheses is okay because it's always positive. Lastly, this right here, look at 4 as 2 squared. Why? Because this is the inverse tangent situation. So, this right here, we have -3, so I'll just put on -3. And remember, the formula is 1 over a, so we will have the over 2 right here. And then we have the inverse tangent of x over a, which is 2, like that, right? So this is it. We are all done now. So I'll just erase this, and I will tell you, don't forget the plus c. This right here is the answer. As I told you, this is the one that might take the longest in terms of the computational things. All right, let's go on to number 10. All right, so hopefully you guys are okay with this. Now, number 10. And for the people who missed the live stream, I'm sorry, I just decided to do the live stream like today all of a sudden because I want to get this out. And when I do live stream, I will make sure that I will get this done, okay? Sometimes if I do videos, if I'm not so satisfied with the video, I will keep recording, and yeah. But anyway, x plus 1 over square root of x dx. Help me out in the chat. What shall we do right here? What shall we do right here? We don't have to do any substitution. You don't need to do the let u equal to square root of x. Split. That is correct. We just have to split the fraction. That's it, right? For this question, it's actually that's it. So have a look. This is the integral x over square root of x. It's the same as x to the 1/2 power. So perhaps I will write that down. Remember, square root of x. Okay, look at that as the 1/2 power. And then next one is just plus 1 over x to the 1/2 power dx that. Well, simplify this before we integrate. This is the integral 1 minus 1/2, right? Because we're reducing. So we get x to the 1/2 power. And then we are going to add, this is going to be negative power now. So x to the negative 1/2 power dx. All right, reverse power rule. Right here, add 1 to the fractional power, we get 3/2, and divided by the new power, which is the same as multiplied by its reciprocal, so we have 2/3. Right here, do the same. Plus 1, we end up with 1/2. Divided by this, we multiply by 1/2. 2 over 1, I'm sorry. This is the time that I cannot go back to the video and edit this out. If I make a mistake, I'm sorry. Anyway, this right here, 2 over 3, and you can just write it as x to the 3/2 power, and then plus 2, and you have x to the 1/2 power. You don't necessarily have to put them into the square root form. Yeah, so this right here is totally okay, right? So that's number 10. Now, number 11. Let me put down the question for you guys on the board first. This right here, we have to integrate e to the x cosine x dx. A classic one. Okay, what shall we do for this one? Take a look. What shall we do for this one? Let's see who can get this right. Integration by parts twice. DI method. Is there anybody who would like to use the UDV method, like the one I showed you guys earlier? All right, so I'm just going to do the UDV method, if you guys don't mind. U and dv, and then the plus, minus, plus. Nobody says you really have to put d and I right here. If you put d and I right there, people might get mad at you. UDV method. Let me just integrate. Let me just differentiate e to the x, right? This way, you see, we get e to the x all the way. And then I'm going to take the challenge and integrate cosine. So we have cosine, integrating cosine, we get positive sine. Integrating sine, we get negative cosine. So, have a look. E to the x, and here we have cosine x. The function part repeats. So this is a repeating situation. This is all we need. So remember, this times that will give us the first two parts of the answer. And this is how I like to do it. I'm just going to write this down right here again. Integral e to the x cosine x dx. This is the same as first part of the answer, e to the x sine x. Next, this times that is positive, and then we have e to the x cosine x. And lastly, don't forget that when you multiply by a row, this is still an integral. And positive times negative, we have a negative integral though. Integral of what? Yes, e to the x cosine x. So the last one is also e to the x cosine x. Let me just not write the dx for the first time ever. What we can do with this is, of course, let's just add this on both sides because this is repeating. So add e to the x cosine x, and then add e to the x cosine x, right? So that way they cancel. And you'll see this right here will just be 2 times the integral of e to the x cosine x dx, and it's just going to be all that. But let's just divide everybody by 2 right now. So let's just divide this by, and let me actually just write down the line one more time. So this is e to the x sine x plus e to the x cosine x. Now divide everybody by 2. Integral e to the x cosine x dx. Ladies and gentlemen, 1/2 e to the x sine x, and then plus another 1/2 e to the x cosine x plus c. Right? Just like that. Right? And I purposely make the numbers easy so you don't have to deal with like weird fractions. So that's it. Yeah. So just 2 or 3 more questions to go, and that's pretty much it. So let me erase the whole thing here. All right, for number 12, it might look the scariest one. Have a look. We have the integral of 1 over x times the square root of x to the 20th power minus 1 dx. It might look the scariest one because we have the x to the 20th power. So that will take suggestion. What should we do? Tricks up, integration by parts, partial fractions, use up, other techniques, multiply by the conjugate, or maybe linear algebra differential equation. I don't know. So let me see what do you guys come up with. So tricks up, whatever you want. And let's see, multiply by x19. Let u equal to x to the 20 minus 1. Tricks up. And Wolfram alpha. Well, unfortunately, that's not. If the student use Wolfram alpha, that's considered cheating. Simplify the root. Well, this is one of the examples that if you use the wrong method, this will not go anywhere, right? And I actually give my student a hint for this one. It's also on the PDF if you guys go to the description and just check out the file. I actually told the students that just go ahead and let u equal to square root of x to the 20th power minus 1. So this is the hint I provided. And with this hint, I think this question is totally fair. And my students, if you guys are watching, whenever I give you a hint, use it. If you have this hint in front of you and still want to do tricks up, or integration by parts. You're breaking my heart. Anyway though, right here, this is what we have, and then let's just differentiate this right away. The square root, right? So we get 1 over 2 square root of the inside, which is x to the 20th power minus 1. And don't forget the 前度multiplied by the derivative inside, right? Which is 20x to the 19. And then we have the dx right here. Let me isolate the dx by putting the reciprocal on both sides. So we get dx being equal to 2 square root of x 20 minus 1 over 20x to the 19 du, like this, right? Alright, let's see if this is actually legit or not. Have a look. This right here is the integral. 1 is 1, and then we have the x. And this thing is what we told to be the u, so just put that down right here. That's pretty good. And then the dx is all that. And of course, man, I should have reduced this. This is 1 and 20. 1 and 10. Anyway though, I'm about to put this down right here. But we do notice that this right here, square root of x to the 20 minus 1, it's exactly what we call the u to be. So I will actually put down u, right? This is u on the top, over 10, and then x to the 19th power. And then here we still have the du right here, right? So u, and then this right here should be in red. And then the fraction part should also be in red. There we go. And now let's see if this is going to do us any good. Yes, the u will cancel. And yes, the 1 over 10 can go all the way in the front. And then we have to integrate 1 over x times x to the 19, which is x to the 20th power, and then the u right here. Now, I would like to ask you guys, can we write this as x to the negative 20 power, and then do the reverse power rule? So let me know, what should we do from here? Can we just do the reverse power rule? Well, maybe is the answer just 1 over 10 ln of x to the 20th power. That's even better, that's even quicker. So think about it, what should we do? I see a correct answer. So I see a lot of correct answers. Yes, x to the 20th power. Look back here. We have x to the 20th power. Remember, x cannot be in the u world, right? Let's square both sides. So this right here is telling us that we have u squared equals x to the 20th power minus 1, and then add 1 on both sides. X to the 20th power is u squared plus 1. So now we can actually put this right here, and I will write this down right here for you guys. This is going to be 1 over 10 integrate 1 over, again, x to the 20th power. We have to write it as u squared plus 1 because we are in the u world. And then from here, this is actually so easy to integrate, right? If you remember, the answer to this is just inverse tangent. So we get 1 over 10, and we have the inverse tangent. And the input is u. U is that, so I will just put that down. Square root of x to the 20th power minus 1. And then this is like 1 square, which doesn't affect the numbers. That's it. That is the answer. Plus c, that is it. Just like that. Okay, then let's see. Next one. Well, what's the next one? We have the integral. And if you haven't noticed, I haven't do a sine cosine integral. Yes, this is the one. Integrating sine to the fourth power x, cosine to the third power x, dx. That number 13. All right, I'll take suggestion again. What shall we do right here? Just go ahead and answer that real quick. U equal to sine square x. Oh, that is not the correct substitution that we have to do. we are not going to do cosine x is equal to t either. No integration by parts. Call Dr. Pi M, he's teaching right now. So, what can we do right here? Can you guys hear me? Can you guys hear me? Yeah, you guys can hear me. Yeah. Yeah, you guys can hear me. Yeah. All right. So for this one, when you have an even power for sine and odd power for cosine, pull out one of the cosine factor. So the way to do this is that integral sine to the fourth power x, and write this as cosine square x times cosine x. Why? Because you want to have a cosine factor right here, and right here we can actually write it in terms of sine x. This right here is sine x and then to the fourth power already, but for this we can easily change it with the identity, right? So here, let me just write it down. This is the integral. We have sine to the fourth power x, and this is just 1 minus sine square x, right? And then have a look. This part is just in terms of x, in terms of sine x. And then the very last thing right here is cosine x dx. So what can we do from here? Well, we can just do a u sub. You see, this is the first portion. Go ahead and do the first. Go ahead and do the u sub for the first portion. We have u is equal to sine x, and this way du is exactly cosine x dx, which is exactly what we have here. Very nice. So then we get the integral. This right here becomes u to the fourth power, and then we continue. This is 1 minus u squared. And what's this guy? Yes, this guy is just du. So let's go ahead and put down du. And now we can just take care of this by multiplying this out and then do the reverse power rule. So this is the integral. We'll actually put this down right here so I save some more space. Distribute this, we get u to the fourth minus u to the sixth, and then we have the du. And now I can actually write down the answer for you guys already. Integrating u to the fourth power, we get 1 over 5 u to the fifth power. But u is sine x, so I'll just put down sine x right here. But to the fifth power, so let's put down the little 5 right here. Continue, minus integrating this, we get 1 over 7. U is sine x. And then don't forget, we still have the 7th power. So that's it. And again, if you know the exact method to use, then this right here is just pretty straightforward. But the hardest part of doing integrations, when everything comes to you all at once, the hardest part is to think about which method are we supposed to use first. If you use integration by parts at first, maybe it works, maybe not. Maybe we'll go really far away. I don't know. If you use substitution right away, I don't think that's going to work. But if you bring up some trig identities, I think that's going to be a great idea. Follow the strategies that I have demonstrated in my previous video and also in my lecture, so that's about all. All right, number 14. Last question for you guys. If you guys look at the file, this is the one I have for you guys. Integral sine of x over x to the x power, and then we have to add ln x dx like this. All right, so let me just take a look. I have to take some suggestion for this. It's in blue, it's kind of scary, so help me out with that. All right, let's see if you guys can do this one or not. Come on, I need your help. Help me out. I need a suggestion. Like, come on, you guys, help me out. Man, this is the last question I have to do so I can pass the Calc 2 test, right? Help me out, you guys. Man, nobody is telling me what to do with this. I'm sad, crying. Come on, otherwise I cannot end the live stream. Help me out, you guys. Can we just cry? I'll cry. Nobody is telling me how to do this. Maybe to put a u for sine x, let u equal to... My marker is running out of ink as well. Oh my god. This is what a horrible day, right? How do you differentiate this guy? This is just going to be cosine x. Oops, why did I put on question mark? But I don't have a cosine x. No. I don't think so. All right, so I'm gonna leave you guys this, right? Because nobody wants to help me out. Nobody is telling me what to do with this. So I'm gonna leave this to you guys, right? And yeah, that's it for the live stream. Thank you guys so much for watching. And let me know if I should do a live stream next time when I go over my homework solutions. If you guys find this interesting, I'll be willing to do more for you guys because nowadays everybody is at home, like online classes. So hopefully this can provide some value to your study as well. If you missed the live stream, I'm sorry, but hopefully the replay can help you as well. And if you have questions, just leave me a comment and look forward to read them and answer them, right? So that's it. Thank you guys so much for watching and bye.